In these next few problems, we're going to be finding the inverses, and we're also assuming that these are one-to-one functions. So for this first one, f of x equals log base 4 of x. We change f of x to y and rewrite it as y equals log base 4 of x. We swap the y's and the x's around. So anywhere I see a y, I'm going to call it an x. Anywhere I have a x, I'm going to call it a y. And now solve for y. So I need to get rid of the logarithm, and we don't want to say the opposite, but the inverse of a logarithm is an exponent. So I need to rewrite this as an exponential. I look for the base of the logarithm. That becomes the base of my exponent. So 4 to the x, remember a logarithm is always equal to a power, equals y. And you have y already solved for, so that is your inverse. F inverse of x equals 4 to the x power. Logarithms and exponents are inverses of each other. So if I start out with g of x equals 4 to the x minus 2, this is an exponential. I should expect to see a logarithm in my final answer, because again, they're inverses of each other. So change g of x to y equals 4 to the x minus 2. Swap the x's and the y's. So x equals 4 to the y minus 2. Get the y term by itself, so I'm going to have to move the minus 2 first. Add 2 to both sides of the equation. X plus 2 equals 4 to the y power. Now you can't divide by 4 because that's not hooked by multiplication. That's an exponent, so I need the word logarithm to get me out of this mess here. So log base 4 of something equals the power. The power happens to be y. And what goes in for the argument is x plus 2. You have y already solved for, so that is your inverse. G inverse of x equals log base 4 of x plus 2. All right, so again, the next one is an exponential, so I would expect to see a logarithm in my final answer. Rewrite it as y equals 2 to the x plus 7. Changed h of x to y. Swap your x's and your y's. So x equals 2 to the y plus 7 power. All right, and from here you need to get rid of the exponent by rewriting it as a logarithm. Log base 2 of x equals the power y plus 7. Solve for y, subtract 7 from both sides of the equation, and we have log base 2 of x, our x is in parentheses, and then just a minus 7 equals y. So our inverse, h inverse of x, is equal to log base 2 of x minus 7. For example 62, which function families have inverses? Hint, think about the graphs. Do they pass the horizontal line test? So if I think of a linear function in the form y equals mx plus b, all right, I can have a line with a positive slope, and that's going to pass the horizontal line test. I can run a horizontal line across that line. It won't hit twice. I can have a line that's going downhill, and it too will pass the horizontal line test. However, a horizontal line with the equation, for example, y equals 2, isn't going to pass the horizontal line test. It's going to hit in a whole lot of different places. So in this case, a linear function will have an inverse as long as it's not a horizontal line. So all linear functions except horizontal lines. Remember, a vertical line isn't a function. That's an x equals. You can't solve for y and call it y equals. So we don't worry about the vertical line, but a horizontal line does not have an inverse. Right? It fails, rather, the horizontal line test. Exponential functions, we saw in our previous examples above that's okay. We're okay there. They will have an inverse, and log functions as well. That's a yes as well. All right, we had logarithmic and exponential functions have inverses of each other. Power function, though, you got to watch out for. All right, think about some of your power functions. We had the spaghetti strand. That will pass the horizontal line test. And that spaghetti strand is an odd power, so that's cool. But if it's an even power, where it has y-axis symmetry, then that's going to fail the horizontal line test. So if it's an odd power function, it's okay. Odd power functions will have inverses. But even-powered functions won't. Okay, they won't have an inverse.